Okay, number 7 now. There's a 2 in the front, but nothing else will divide by 2, so that's going to be part of the factor. It's going to be part of the first. The first is going to have to multiply to 2, while the last multiplies to 49, and then the outer inners will have to make 21. So the only thing that makes a 2 is 2x times x, so there's 2x squared, so that part's done. The 49, I don't have too many choices. It's 1 and 49 or 7 times 7. Now when I take a look, when I look ahead and I see this 21, if I put the 7 there, 2 times 7 will be 14. And if I put the 7 there, so if I go 7 and 7 like this, the outers 2 times 7 is 14, the inners 7 times 1 is 7. If I add that and add that, so it'd be 7x and 14x. If I make both of those positive, sure enough, 7 plus 14 is 21. And now just to check the last one still, the 7 times positive 7 is still positive 49. So that one was pretty easy, and it's easy because there's not really that many choices. The first only had one choice, 2 and 1, and the last one only had 2 choices. It gets harder when there's more and more and more choices. So number 8, I can't divide out a 3 because of the 8, so that 3 is going to be part of the first. So I need something that multiplies to 3n squared. Well, again, only one choice, so this one's not going to be too crazy. But now there are multiple choices for 56. I have 1 and 56. We could have 2 times 28. 3 goes into 56 at 6. No, 3 does not. Does 4 go into 56? 56 divided by 4. Yes, 4 and 14. 6, no. 7, no. 8, no. Oh wait, yeah, 8. 7 and 8 actually make 56. So now there's 4 possibilities, so I got to get some combination that adds up to 8 while maintaining a negative 56. So since it has to be negative 56, one will have to be plus and one will have to be minus. So these are going to have to subtract together to negative 8. Well, I'm going to hold off on the 56. I'm going to concentrate probably on these. And since that's a small number, I would probably pick 7 and 8 to get started. So maybe 8 there and 7 there just to see. So 3 times 7 is 21n, and then 8. Okay, that is not going to subtract to 8, so that's not it. So I'll switch them around and see if we got 8 and 7, see if that does anything else. Now the inside is 7. 3 times 8 is 24. Those will not subtract together to be negative 8 either. So it doesn't look like 7 and 8 is it. So I'll try the 4 and 14. Now, I don't think I'll put the 14 here because 3 times 14 is going to be really big. So I'll put the 14 there and the 4 there. Okay, 3 times 4 out there is 12. 14 times 1, and there's 14. Those will not subtract to negative 8. I don't think I need to try it the other way around because if I put a 14 there and a 4 there, 3 times 14 is 40 something, and then that's never going to go to 8. So it's not 4 and 14. So I'll try the 2 and the 28. Okay, I'll put the 2 there and maybe the 28 there. All right, 3 times 2 on the outside makes 6. 28 times 1 is 28. Okay, those do not subtract to negative 8. If I try it the other way around and put the 2 out here, oops, that's what I just did. I'll put the 28 out there and the 2 there. Well, 3 times 28 is almost 90. That's never going to subtract to 8, so it's not that one either. So how about the 1 and 56? I'll put the 1 there and the 56 there. Now the insides make 56. 3 times 1 on the outside makes 3. 56 times 3 is never going to make it. And if I put the 56 out there, 3 times 56 is way too big, so that one doesn't make it either. Nothing factors. That's called not factorable. That means there is no combination of something like this, when you do all the multiplying together, that ever ends up being that combination. Okay, number 9. I'm anticipating number 9 to be a little bit tougher because now the first term has choices and the last term has choices. So we're going to have a lot of combinations that have to go make a negative 23. Now, since this is negative, that's 14. One of them's going to have to be positive, one of them's going to have to be negative so that they subtract to negative 23. Oh no, that's not true. Since this is positive, they both have to be the same. They'll either both be plus or they'll both be minus. Well, they'll both be minus in order to make negative 23. So I know both numbers are going to be negative. So in effect, they have to add to 23. Okay, the 8. The front term could be 1 and 8 or 2 and 4. The last term could be 1 and 14 or 2 and 7. Okay, so we got to have some kind of a method to keep track because the 1 and 8 could go with either one of these, or the 2 and 4 could go with either one of these. Now, since this is a kind of a medium-ish size number, I'm going to start with the 2 and the 4. And then over here, I'm going to start with the 2 and the 7. I actually hope I don't get it right off the bat, just so that you'll see we got to try a bunch. There's 8, and there's 14. Okay, 8 and 14 is not going to add up to negative 23. Even if we subtract them, it won't be. So the 2 and the 7 doesn't work. But now I've got to change the order. Before I leave out the 2 and the 7, I'm going to try 7 and 2. See, that's going to change it up. Now the inside's 4 times 7 is 28. The outside's 2 times 2 is 4. 28 and 4 also cannot go to 23. So now I will throw out the 2 and 7. Okay, so I'll try the 1 and 14. So maybe I'll put the 1 there and the 14 there. 2 times 14 is 28. 1 times 4 up there is 4. 28 and 4 will not go to 23. If I switch them around and make this the 14 and this the 1, 14 times 4 is 56. And 2 times 1 is 1. Well, 56 and 1's not going to make it. So those didn't work. So the 2 and the 4, neither one of them combined up with those two. What that means is the 2 and the 4 is not it. Okay, so I'm going to start over so I can have some more space. So it's the 1M and 8M. Okay, now I'm going to start over with the 2 and the 7. So I think I'll put 2 here and 7 there. Okay, 2 times 8 is 16. 1 times 7 is 7. Okay, if I add those together, that actually makes 23. I need negative 23, so if I make them both negative. Okay, so now they'll both be negative 23. And now negative 2 times negative 7 is positive 14. So it met all the requirements. A negative times a negative is positive 14. The outers and the inners add up to negative 23. And 1 times 8 is positive 8. There it is. So when the front has options and the last has options, you got all kinds of different combinations we got to try. So look at all the options 18 has. Oh man. Well, before I go too crazy, I can at least divide it all by 2. If I pull a 2 out of that, that'll make it 9n squared minus 24n plus 16. So now at least the front only has 2 choices, 1 and 9 or 3 and 3. The back could be 1 and 16, 2 and 8, or 4 and 4. Okay, I'm going to try the 3 and 3 first. I'm going to try the 3 and 3 first because then I don't really have to switch the order here. You'll see here in just a second. So I'm trying to go to 24. Well, recognizing that I need a 24 there, and 3 times 4 is 12, I'm going to stick the 4 and 4 in there. Okay, there's 12, and there's 12, and I need that to be negative 24. So if I take a negative 12 plus a negative 12, I can get a negative 24. And now negative 4 times negative 4 does make positive 16. So I still have positive 16, have negative 24, and 3 times 3 is positive 9. I got that one on the first shot. Okay, number 11. There's not 3 pieces here, but they both can be divided by 2, so I'll divide out a 2. And there's an m squared in both of them. I can divide out an m squared. So if I divide the 10 by 2, I have 5, and I take 2 of the m's. So this first term, when we divide out a 2m squared, leaves a 5n. And 8 divided by 2 is 4, and we took both m's. Okay, see, that's not the same form as these these are called trinomials. You need a second power, a first power, a no power. Well, this doesn't have all of that, so this is done. I was just like the first one where way up at the top where we just factored out an x. Well, we just factored out a 2m squared. You want to pull out as much as you can at the beginning. Okay, notice that these all have a k. I can pull out a k. And then I can't divide anybody by anything because of the 13, but I am going to pull out the negative because the front term, it's much easier if it's always positive. So I'm going to divide out a negative k. So if we take the negative, that makes it positive 6, and we took one of the k's. We took the negative, so that makes it positive 13, and we took one of the k's. And I took a negative, which makes that minus 63, and we took the k. Okay, the front term over here could be 1 and 6 or 2 and 3. 63 could be 1 and 63, 3 and 27, is that right? No, 3 and 21. 4, 5, 6, 7, and 9. So there's my options. Now 13 is a pretty small number, so I'm going to start out and try the small ones first, like 2k and 3k. And then maybe I'll go as small as I can here. So I'll match the 2 up with the bigger one and the 3 up with the smaller one. Okay, so there I got. Now I need a negative 63 here, so these are going to have to be opposite signs. So they'll have to subtract to be 13. 2 times 9 is 18, and 21, that's never going to make it, so it's not those. Let me switch the order to 9 and 7. Now 9 times 3, and there's 27. 2 times 7 is 14. Will 14 and 27 become a 13? Actually, yes, if I make this one positive, so the insides have to be positive, and the outsides have to be negative. Okay, the insides and outsides add up to positive 13. This is a 9, positive 9, and negative 7 multiplied to negative 63, and 2 times 3 is 6. So we have it. Now don't forget this piece. So it's negative k is one of the factors, 2k plus 9 is another factor, and 3k minus 7 is a third one. And that's how you factor.